Hey there guys, and welcome back. So as you can see, the program is running now, and this is what we would be expecting. Plan in the future is to actually change the starting soon down here and just put that on the computer screen, but otherwise, as you can see, is working as intended. The number of bugs we had in here and my understanding of the bugs were a bit insufficient. Well, my understanding of the bugs was insufficient. The bugs were plentiful, but regardless, we have quite a bit to go over. So, I mean, yeah, here's GitHub here. We have quite a bit to go over. So, over to VS Code. And actually, I can turn that one off because we don't need that one anymore. And it looks like I got to reassign the VS Code to the actual animation program because it is currently assigned to something else. So half a second. Don't know how that happened. To enter sample, there we go, and off we are to the races. So let's see. Basically, last time we left you, we were doing the pathing to collect from the printer. And I ran it, and it took forever. Like, literally. Like, it was not going to finish. It actually hung up, and whenever anything hangs up in a program, you're pretty safe to assume that either the input is just too freaking large, or it's in an infinite loop. Now, 9 times out of 10, it's actually the infinite loop part. It's not actually the size of the data. To have as much data as you would need in order to actually have a program freeze up because it's processing the data, that actually has to be like really massive. I've had it happen before, but this was not one of those cases. However, I assumed it was in this case because I assumed, and it actually was, to be fair, happening. I assumed that our pathing was going on a pixel per pixel basis. So whereas we were pathing over, let me go ahead and pull the A-star map up. So as you can see, this is the A-star sample that we had before, and this is very small. I think this is 10 by 10 pixels, if I recall correctly. So the number of pixels that it needs to traverse in order to find the exit on the map, or the target point on the map, whatever, that number of pixels is very small. Whereas with our TK enter sample, and I'll toss that back over here, this one is 1080 by 720, I think. Oh no, 1920 by 1080. Let me double check that. Regardless, the point is that the number of pixels are extremely large, so I assumed that was the problem. As it turns out, that was not the problem. However, we did make it significantly more efficient by me tossing this in here. So basically what was happening before in this area right here, this is the get our valid moves in order to determine the next the adjacent nodes that we can travel to in the A-star algorithm, right? So valid moves, and then the coordinate actually should be our step length because our animation program only moves us per step length. That's how we have it set up. So because that's how it's set up, instead of moving 1 pixel and just getting the adjacent pixels, we actually want the step length square pixels. So if our step length is, let's say 16, I actually do not recall what it is at the moment. Let's see, canvas sprite size divided by 4. So sprite size divided by 4 is 16:8. So it's 8 pixels are our step length. So instead of going per 8 pixels, we were going per 1. So that's 8 times faster by adjusting this code. However, this code did not fix my problem. So because this code did not fix my problem, I started digging and I did a whole lot of other stuff. So first thing that is extremely important that I did, actually, you know what, let's just touch on the little things that I did over here on, where is coordinates? There we go. So I don't recall if this was in here last time, but I added step length to all these so you can convert between pixel coordinates and step length coordinates. So that was added. Again, I can't remember if I actually did that before last session or not. However, that is definitely in here now. And now that's out of the way, so you understand it. There's also this round 2 step length just to keep everything square, so it rounds you down to the correct step length if you have a pixel in between step lengths. However, the more important things that I'm getting to is over here on sprite, we now have, or is this where I want to go next? Let's see. Yeah, I guess over here is where I want to go next, because this is the most meaningful change. Where are we at? There's sprite. So here's sprite and self.virtual. So as we're moving our sprite throughout the map, when we're doing algorithms and whatnot, trying to determine what's going to happen, certain callbacks should not be called if we are not actually moving the sprite. Now, this actually is not a sufficient solution, I don't think, moving forward, but we'll see what happens. And the reason I say that is because, for example, in this scenario, this virtual ends up getting used to allow us to move without triggering certain callbacks. For example, without collecting from the printer, which is a problem that came up. So this was useful for that. However, if, for example, we want to trace a route through a spike field, okay, and you're guaranteed to have to step on spikes, and your character has to take damage, in that scenario, then we want to be able to take the damage, but then revert to our previous state. And that's not necessarily going to be efficient here. So we may have to continue working on this. But, however, in situations like the A-star algorithm, where we don't want the character to actually be moving, we just want certain callbacks for the character moving, we then can set this as a virtual sprite movement and turn it off at the end. So, for example, if we come down here to move on the mobile sprite, valid moves, turn on virtual, and then we can move the sprite, have the engine move the sprite, and turn virtual back off. That way, any callbacks know that is not virtual, or that is not an actual one. For example, here in the move. So after this point in the code, the rest of this is animation, right? We don't actually want to cycle the animation, and this is a problem that came up. Separate, this is a separate bug that came up. And because we don't want to change the animation cycle counter when we move, when we're doing, for example, the A-star algorithm, and we're moving around the map virtually, if we did keep on cycling this, then we'd actually end up with a random starting point when we did start moving. So that is the point of virtual, and that is the first major change we got here. Second change, and this is pretty major, but it doesn't play in as much with our, let's see, utils. I guess I'll just find it over here. It doesn't play in as much with our specific bugs, but it is a major change. Here's engine. Where is utils in engine? There it is. I changed the collision callback. So the collision stop rule was this code right here up until basically right here. Okay? And then this returned false from this point on. The reason I did this is because this collision callback, or this collision rule, actually, is a rule that we're going to actually want to use a lot. For example, when we collect from the printer. So, how we're collecting from the printer right now is we're running into the printer, right? And when we run into the printer, we want to collect from it. So, that being the case, in the utils, and I just lost it again. Let's close some of these out. So I stopped doing this. Entities can close. Sprite can close. Canvas, do I have anything in Canvas? I don't think I do. Oh, there we go, utils. It was to my left. So, in that scenario, we can recreate the collision callback rule, as you can see here. And we can instead, let's come down here to rules, collision callback rule and unpause printer. So now when it gets a collision, we can check first off that it's an actual move instead of a virtual move. Again, that's one of the reasons why virtual is useful. And then we can check the sprites involved, me and the printer. And then we can check if the printer is paused. If it is paused, then we can unpause and cycle. And this now gets called down here. Where's my callbacks? There they are. So now that gets called on the movement listener. And because this does not necessarily automatically return false now, as you can see up here, we are returning, and I passed it. Unpause printer. We are returning none, right? So none is not false, which means that in our listener, and that would be over in canvases, we're listening for the response is false. So because we're not returning false, it doesn't cancel the move. So because it doesn't cancel the move, it can continue doing whatever it wants. And otherwise, for our collision stop rule, because all this code is basically the same, all I did was just change collision stop rule to be a collision callback rule, and we take that event and automatically return false because the collision stop rule says stop no matter what if we run into something. So this just always returns false. So that is the next major change, changing the collision callback rule, making it more flexible for future usage. And next up, we should circle back around to the problem that actually was going on with this hanging up on the printer. Now, what took me so much time, and the reason why this wasn't done a lot sooner, is I actually went through a bunch of iterations on how I thought it would work best. And I also had to narrow down the fact that I had to narrow down what exactly was the problem in here. So, to get around the hang up problem, to stop it from hanging up, again, my initial assumption was that it was simply the size. So what I did was I reduced all this stuff to step lengths instead, a step length measurement instead of a pixel measurement. And I ran it like that, and it did not hang up. However, I started running into a problem where instead of hanging up, it would get stuck on the desk. And if I pull this up, do you guys see this on screen now? Okay, let me unhide that. There you go. So when my character is up here, and let me point on the actual TK. So when my character was up here and it had to path down to the printer, it was actually getting stuck on the desk. And that took me a long time because I had misdiagnosed what had gone wrong to figure out that actually the reason it was no longer hanging up was not the pixel size, but rather because I was doing step length, things were not lining up exactly as they were in real life. So it was having a path where it thought it was just barely shirking past the desk here, when in fact it was overhanging by just, a couple pixels. So I had to figure out what was going on wrong with that, and that took up a good bit of time. Now, as it turns out, the actual problem here, well, let me just say really quick, square distance, it was a much better heuristic, I found, than linear distance because it gave a much coarser result. So I changed the square distance. However, the actual problem was that our A-star algorithm kept on running into the printer because it was trying to go printer.location. Right? This is where we're trying to get, which means that the very last square I was trying to path to was the printer square. And if we're going directly to the printer square, the collision stop rule down here is going to stop us. And therefore, we're never going to actually be able to get to the endpoint. Now, as I said, there are a number of ways that I considered and I implemented to solve this. And I decided at the very end, just this afternoon around about 4 p.m., so a couple hours ago, I decided this was the best solution, was to simply set the printer to z-index -1, so it is no longer available for collisions. And I actually had to come over to utils and fix that because that is not something we had done before. The find nearby sprites, the other sprites here. Let's see. Okay, it's not actually here. Okay, there we go. It is in collision stop rule. I take that back. So in collision stop rule, this was simply canvas.sprites before. But again, anything that has a z-index of below 0 is not actually a sprite. It is not actually a visible sprite, and therefore cannot be collided with. So for that reason, I had to change this code here to only get the visible sprites to make this result work. And again, this I think is the best way to solve this, is to just make it so you cannot collide with the printer, and then you can move into the printer square. So now at the very end of this, we get this path, and this path starts with our square. That's why I'm popping this first cell out, because we don't want to move into our own square. Technically speaking, the program currently throws an error when that happens. That's something I should fix, frankly, but the fact of the matter is that it's still wasting a cycle, so we should pop it off anyway. However, the very last step, when we move into the printer, then the unpause printer function will fire because we're moving into the printer now in real life, because again, Z index is now the original Z index. And that should be a Z index, not negative Z index. So regardless, that is now functional. All that is now functional. And it works as intended. Now, we can talk about a couple of the different ways that I ended up considering fixing this. The first one that I considered and did not actually implement was to check if our sprite shared or was adjacent, I should say, to the printer. Now, that is the most logical, honestly, way to do it is, okay, the guy is right next to the printer, now take a move into the printer. We would just add that to the very end. So we would put a check down here to say, is it adjacent to the printer? Or in here in this algorithm, and I'll get to this because this is another change I made. And then if it is at the very end of the path, move into the printer. Again, very reasonable. I had a little bit of a problem rationalizing what exactly it means to be adjacent to the printer, because there's a couple different things, right? First off, we got to consider the printer's hitbox rather than simply the printer sprite. So the printer's B box is different from the printer's sprite, hitbox, and et cetera, et cetera, et cetera. So we have to consider that. So there's those complications there. And then how exactly do you define that something is adjacent is some math that I would have had to work out, and I decided not to. But that was one possibility. Another possibility was to predefine locations. So for example, either pick one square, the square right underneath the printer, which would be logical, because generally speaking, people offload the printer from in front of the printer. They don't like reach around the back and then take the print off the back of the printer, right? Most people. I'm sure there's some weird people out there. And by weird people, I mean people with like print farms probably, who just are in a situation where it's easier for them to offload from a different position. But point being is that offloading from the front of the printer makes the most sense. So that was another possibility. So I did try that one. I ran into a weird bouncing problem where the pathing kept on trying to move in the opposite direction when I started out right next to the printer. So if my sprite happened to be right next to the printer and then it had to path to the printer, it wanted to move away and then move towards the printer, and then it actually ended up stuck in a loop. Now that is something I probably could have fixed, but it was not really worth my effort, I didn't think. So we did not fix it. The next one would be, let's see, what else did I do? I'm blanking on a couple of the other ones. The last one, though, unless I think of the other ones as I'm going through here, because I know I had at least two more. I just can't remember what they were, solutions. But the last, not the last one, but one of the important ones, because it caused me to change the algorithm itself, is to provide a callback. So if we come over here to AI algorithms, you'll see that now the target, technically this still says tuple up here, but I've got this code is callable. Okay, if it's not callable, we convert is target to node.coord equals target. Otherwise, the callable should accept the current node as its argument right here. And what that allows us to do is, for example, in a situation in which we want to check if it's adjacent rather than we're going to a target square. So the A-star algorithm would actually be able to, in that case, check callback is adjacent as its is target function with node, the current node. And then if the node is adjacent, obviously it returns true, and that is considered quote unquote the target. So if we come down here to not is target, right? So current node would get passed into is target, and then if that's true, then we go ahead and exit out, and current node is a good square. So that makes this algorithm a lot more flexible, and it's a good change to have in here. I do like that. However, I did not end up using it. So that is that change. Let's see. Let me take a quick look at the GitHub to see if there's anything else. I mean, there are definitely other things. Oh, first off, I don't know, again, I don't know if I saved GitHub before, or pushed to GitHub rather, between last session and this session. But in case I didn't, down here in systems, this was something I always was supposed to implement, okay, and just never did. And that was getting all the types of sprites over into two-dimensional. That way you only had to import from two-dimensional. You didn't have to import sprite to get the static sprites and the cosmetic sprites. You just import everything from two-dimensional. So that was one thing that I did that, again, was on the checklist and is now done. Again, I don't recall if that is something that was done before last session, but it is absolutely done now. So, similarly, let me just take a quick look to see if there's anything else in here before I get to that one that I was about to say. Actually, here's one that I don't know if I changed before last time or not. Okay, so over in sprites, and you can tell me whether or not I told you or showed you this one last time. Over in sprites, we changed it so that animations was handled by the base sprite. So before we just had idle animations in base sprite and no coordinate systems. We didn't have any coordinate systems in base sprite. As part of the move over to two-dimensional, in order to, well, not necessarily in order to, but as part of porting everything over to here, I made it so that all sprites were coordinate aware, even though all these other sprites do not use it at all. And I lost sprites again. All right, Control K, enter, and now let's hit sprites. There we go. So now the base sprite, which everything is based off of, is coordinate aware and can assign animations to the coordinates. So that is a major change. And the other change that I saw was, I believe, set animation. Where's set animation? Up here. I don't believe I had this before. So this reset call. So before, if we were changing the current loop, I believe we just automatically set it to 0. But now, if we want to, we can go ahead and keep the animation current index at whatever it was, assuming it is, as you can see here, within the length of the current loop. So if we go to a shorter loop, then we don't run into an error because it's the current index ends up outside of it. So that is that. Boom, 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 boom. Yeah, okay, so now I'm looking through the rest of these changes in GitHub, and actually, yeah, a lot of these changes that we did do last time, and I just did not port them to, I did not push them to main to GitHub. So yeah, that should be everything else. So as stated, obviously the program is now fixed, and now we can move back on to developing our animation sequence here. So the next thing that I want to add, and I've talked about this before, is I want to add meters, and I also want to add a counter. Now that is a little interesting, right? Because with sprites, Control K, enter, there we go. With sprites expect to have images attached to them, typically speaking, and hitboxes and a coordinate system. So this is not actually one of those things. And how exactly we want to handle this is kind of up in the air. For example, you could make the argument that instead of being a sprite, it might be something else, or you can make it the argument that is actually something, it is a sprite type object, it is just a different type of sprite. So whereas we consider this sprite as something inside of the game, it's like what we're building here is in HUD, is what we're building. And you might say that, okay, the HUD fits into the sprite category that we have here. I think there's a little bit of an argument that that's wrong, but at the same time, it is technically graphics displayed on the screen. So if you define graphics displayed on the screen, even if it's part of the HUD, as being sprites on the screen, I can see where we come from with that. The other thing is, technically speaking, the HUD basically has a z-index of infinity. And so I'm saying this because it technically fits into here, right? So it has a location, right? It has somewhere that is on the screen. It has a z-index, and it just does not have hitboxes, which is the only other thing. It does not have animation, or it technically could have animations, but it doesn't necessarily have animations because it's text or bars. So it doesn't necessarily have real quote-unquote animations, but it is animated. So again, I'm just making the argument right now that technically speaking, we could roll that into sprite and then have it be a different kind of sprite, like a HUD sprite. For example, class HUD sprite, define, init, etc. self.z-index equals infinity. Do I gotta import something to get infinity? I can't remember. We should have that over in a star, so I can check. Engines, AI, algorithms, there we go. Okay, so it's in math. Math.infinity. Import math, and while I'm here, let me rearrange some of these guys. So somehow that got auto imported. This module built in, third party. There we go. There we go. All right, now it's organized like I like it. So sprite z-index math dot. Yeah, okay, inf is a, okay, there we go. So, something like this, right? And I say something like this after spending all that time typing, and maybe for now we do leave this right here. Just fix that right there. And use this as a solution. Now, the next problem is that its animations is going to have to be something else. So, so if we want to pursue this, right? If we want to pursue this solution, basically, we're going to have to override animation loop. We're going to have to use a different animation loop, which means that we're going to have to override this here. So what we could do is loop type equals animation loop. We'll put that in, we can't put that in quotes, so we got to do none there. If loop type is none, loop type equals animation loop. Now, one thing I will say here, just to address the elephant in the room, is that I am coding live, and I did say last time that I felt like last session was a bit rambly, which is why I hadn't been coding live. I had been doing mostly reviews and whatnot, or I had been preparing the code ahead of time and then retyping it out from memory is actually what the other thing I was doing. I was retyping it out from memory and then double checking myself if I forgot. I'm trying this again just because one of those things, had a few days off and went, you know what? We'll see. It could be a one-off. It could be whatnot. So it's probably more professional, frankly, to do what I was doing before, which was prepare the code ahead of time, do it from memory as best as I could, checking my notes otherwise, and moving on from there. Probably the best way to handle it, but like I said, giving this at least one more try because I don't like giving up on things the first time. I mean, for example, look at the Stream Deck. The Stream Deck failed like, what, 4 or 5 times? So, one of those things. I like second chances. So, in this scenario, this is now how we can handle this. We can then change the animation. Let's see. Actually. No, I think this is fine. It occurred to me that for HUD types, for example, we have text, we have counters, we have... well, technically, counters and text could be... Well, counter could be a subtype of text, technically speaking. However, the bar, the completion bar, or health bar, or whatever you want to call it, that could be something else. But. Yeah, okay. So, this actually is not going to work here. So, what we're going to have to do, grab that. 4 animation frames in KW. Loop type equals animations, animation loop, if type, or not type of, is instance, or no, is subclass frames 0 animation loop, and get rid of my parentheses because we are no longer in JavaScript. Loop type equals frames.pop0. There we go. So, because this animation is going to get every single last... no, okay. I was thinking this way we could set up multiple animations is what I was thinking. But this actually is probably not necessary. It's probably not ever going to be a practical issue. So... I'm probably overthinking that. Okay, yeah, we'll just move on. Move on as you were. So, let's go ahead and get a counter up here, a counter HUD. And I know it pre-populated this for me, but let's go ahead and toss that in there. And I also like to do this just to be absolute certain, just in case the order changes, because the IDE may not change this pre-generated super call if the order or the elements in the parameters in sprite changes. So for that reason, we're going to go ahead and do that. No. Let us go ahead and the next question is whether or not text and counters, because I want to start out with counter because that's the easier one, whether or not the text and counter is separate HUD elements, or whether or not we want to render that all as one element. I think it's reasonable to, for HUD sprite, accept a label. And let's do this. String. And this is, I believe, coming in either a future or the current version of Python, returning self as part of the type hints. I don't know whether or not I actually have that. I mean, it's saying not defined in this version of what you call it, so it may be in another version of Python. It may be. Let's see. I can do that quick search. Python type hint self. And let's see. 3.11 self pep 373 for the self, and that is, yep, Python version 3.11. So 3.11 introduces it. I'm obviously, as you can see down here, 3.10.7. So we do not have access to self yet as the type hint, but I can leave it in quotes there, and eventually it will be accessible. So regardless, self.label equals label. And now we can move on to counter HUD. HUD counter, counter HUD. Sprite. I don't think I need sprite. Yeah, I think at this point, maybe we do this just to differentiate. So all the stationary, cosmetic, sprite, mobile sprite, they all are suffixed by sprite. And if we just change this to HUD and then suffix all this with HUD, that will help us, even though this is a subclass of sprite, it will help us differentiate, just to consistently differentiate between the HUD sprite elements and the sprites themselves. So, HUD, define, init, self, args, kw, super. Yes, I did not let the IDE do this for me. Args, kw. Let's do this too, just to be safe, because I'm paranoid. All right, there we go. So we, for the counter, obviously, we are going to need, or we're going to want at any rate, a min. Let's underscore. No. Technically, all right, fine. It's cmin equals none. Cmax equals none. And start equals none. And all these should be ints. They don't necessarily need to be ints. They could be ints or floats, but just for the practicality, because I don't like importing union, we will go ahead and, or importing from typing in general, we'll go ahead and put that like that, comma, and self dot min equals cmin, self dot max equals cmax, self dot start equals start. And actually, I think it's reasonable to start at 0 for start. I don't think it's unreasonable to not do that. So we can be confident that start should always be a number. Actually, value is what we should have here. Value equals start. There we go. So the interesting thing here, the interesting thing here is how this renders on screen could technically change between systems, between engines rather. Technically speaking, it change between engines. But, and the reason I bring that up is because our animation. So when we do our animation, first off, our cycle, we're gonna have to override cycle so it is none, so it doesn't do anything, because we don't want the animation cycling on HUD elements in general. Technically speaking, you could have a special kind of animation that kind of a special animation that looks interesting, you know, dances around the screen or whatever as a hub element, so therefore it would cycle an animation. But in this scenario, I don't think so. So let us yeah, I think I'm just going to do a HUD label, define init self parent. I think this is how I'm going to do it. And we can make this again, because we're using loop type up here, we're not actually type checking. We can supply loop type as whatever. And then in here, self.animations, we could call it just idle or something like that, just to be safe. So we could call it an idle animation, provide it to the HUD label, and then the frames, we don't type check at all, right? Let's check really quick that I'm correct about that. Self.current animation. Length of loop. Alright, so we'll have to override length, it looks like, and that is it, I think. Current frame, last frame. Current frame just gets the image, so we're fine there. We're going to go ahead and override that to begin with. Last frame is last frame. We'll have to override that too, I guess. So we're overriding so much at this point that I don't see the point in subclassing animation loop. That's what this is coming down to. So for that reason, we will just make sure that it is duck typed to be compatible with animation loop, but we're not going to bother subclassing from it. Yeah, that sounds right to me. Self.parent equals parent. Define length self return 1. Define cycle self return 1. Self.current frame. Define current frame self. And yeah, this will return an image.image. Let's go ahead and get that up. Tuple. So we're just duck typing here. I almost said tuck typing. Tuck typing. We are tuck typing. Return. Actually, this one we should do something with. So we will come back to this in half a second. This is actually an important one. I just want to finish off with is last frame self bool return true. Okie dokies. This also, nah, for the specific one, never mind. So all right, how I think we're doing this one. Again, this is the big one, the big important one. So let's give ourselves a little bit of space, white space. And I think what we do is we say text equals self.parent.getText. Okay. That will give us the text we got to display on the screen. And now we got to open up Pillow and actually write that to an image. The next question is, what our size is actually another important question. So when the animation loop generates us, it passes frames. Frames is a value, so frames can be, there's nothing stopping frames from being an object, so we can call this options. We can pull a JavaScript right here, call this options, and self.parent equals options parent. Whoops, somehow I deleted that. There we go. Self dot Let me pull up pillow to make sure I've got all this information correct. Python pillow. And let us see. And now, because the pillow organization took over pillow, it's no longer possible to get the pillow docs on the first page. Unfortunately, first page of Google is what I meant. Let's see. Text. Image. Alright, I might be blind. Oh, that's right, it's an image draw, isn't it? Yes, it is an image draw. So, let's see. We do need to create the image size. So we will need to provide size. We will need to provide font, maybe. Let's see if font is actually necessary. Draw. Image draw. Text, there we go. Font is none. So font can be none. What is the default though? Huh. It doesn't say what the default is, but I guess because it can be none, we can do that. You know what? All this stuff is probably everything we need to begin with. So, what I'm going to do here is self.parents.pop or options.pop parent, and then self.text options equals options. There we go. That's an easy way to do it. Draws a label on this canvas. HUD. Yeah, we'll do that. I'm trying to figure out whether this is the correct name here. It is the only thing I'm trying to figure out right now. Counter HUD. I guess what I should do here is animations, yeah. Animations equals none. And then here animations equals let's see. Animations. Okay. Yeah. So that is something I missed. We got to provide also loop type here. So animation loop type equals none. And then we can go ahead and pass that down here. Equals animation loop type. There we go. And let us, for posterity's sake, animation loop. Rut. Yes. Alright, there we go. And now animation loop type equals HUD label. There we go. Actually, we can do that as default. Should be no problem. Equals HUD label. and the comma. There we go. Let's see. Frames is going to be options, right? So what we want to do here is, if animations is none, animations equals I know I said idle before. We could set it as idle to keep everything kosher. But we could also change it to be more specific to text, I guess. Yeah, we'll keep it as idle for the time being. This is going to be animations. And the reason I came in here is for key value. Or actually, no, we don't need both key and value. So for value in animations.values with parentheses, there we go. Value parent, try that again, parent equals self. There we go, assign it as our self. And then we can pass that off, because when we initialize this counter HUD, we can, in animations idle, provide the whole entire dict of options for imageDraw.text. That's how we can do this. The next thing we need to do in label is, again, continue to draw. But more specifically, we need to get a location. So, location, yeah. So we should have location be dynamic, honestly, just in case. So for that reason, what I'm going to say is location equals self.parent.location. Actually, no, I take that back. We don't need to do that. Yeah, we don't need to do that. Let's see. Okay, this is what we do need to do, though. Out of this, we also need size. That's something that I skipped over because I got distracted. Options dot pop size. So size is going to be necessary to figure out the canvas. No, it doesn't necessarily need to be. Okay, yeah, it doesn't necessarily need to be. We could size it based off of everything else, because you can get text size in Pillow. At least you used to be able to get text size. Hopefully that still works. Okay, yeah, text size is... Oh, never mind, it's deprecated. Okay, text box will give me the bounding box. So yeah, that is fine then. This can get pretty complicated, it looks like. Let's see. Yeah, so image font, let me look at this again. Image font. Get size. I'm checking if... So the weird thing is I do not see font size as in... So there's text to render. There's mood, which is not relevant to us. Oh, no. That's the get B box. we got the anchor coordinates. We have the text. Font. Stroke width. Yeah, I am not seeing here were you because the image font instance. Okay, never mind. So the subclasses, it looks like, give you the access to size. That's where you get that from. And we only have one. Okay, no, we don't. We have transposed font and free. What was it? What's this thing called? Free type font are our only two options here. Oh no, there's image font that true type. Up a little bit higher. So, one of those things I should get used to sending you guys over here to the browser window with me so that we're on the same page. Okay, so we can set the font size. So that is a viable option here. Font 1025. All right. All right. So, what I think I'm actually going to do then, because it looks like we got to do this in a two-step process anyway. We will load the image font. So we need to, in this library now, bring in image font, image draw. Okay. And down here in HUD label, we will go ahead and initialize the font. So size and name. Question is can we generate a true type without the font? It looks like we can. A file name or file, but the file is not found. The loader may also search, but it doesn't say what the default is. So I guess we will attempt to do it without font if font is not necessary. And any other options? I don't think we do need any other options. In this case, so yeah, actually I take that back. We need the eventual other stuff. So we'll just get let's do it this way. Get 10 del options size font equals options dot get font none del options font, and now self dot font equals image font dot true type font equals font, size equals size, and I don't think we need any other of those options. It doesn't seem like just yet, at any rate. Maybe we can implement those later, but right now not really necessary. So the rest of the text options will be in options at that point. So at that point, text equals text, location equals, we actually don't need that because we will provide that ourselves. No, I take that back. We do need that. Never mind. It's required. Location equals parent.location. text that, and then the rest of this will be image options or text options. So now draw text. We do need to make a new image, so image equals image dot new dot new. Huh, where's new? Slow up, wait a minute. Oh, that's right. And new is off of, it's not off the image object, it's just off the module. There we go. Derp. RGBA. Size is, we got to calculate. So that would be, let's see, go forward. True type dot get bbox. That's what we need, right? So self dot font dot get bbox text, and the rest of this would be our self dot text options. So that is size equals, and then that will be size, and oh, actually, I guess we do not need location because our parent will put us in location. Yeah, okay. We're good because it's just gonna be anchored to top left. Okay. So new blah blah blah. Background color. I guess that is something else we're gonna want, possibly. We may also want some other stuff, but for right now we're gonna keep it simple, and we will just do zeros. So it is not visible because it has 0 alpha. That is fine with me. We'll just start off with this, and then we can change it later, make it more complex later. For example, having a background image is something we probably should implement, or a callback to create a background image given the size of the label, for example. However, a lot of those things, and the reason I'm doing this like this, a lot of those things can be handled separately as another HUD element and then just pasted behind it. So that is why I am doing this differently. So moving on, that's our image, and then we need an image draw, right? Font, image draw. Yeah, okay, we need it drawing context. Yeah, we need to draw in context. So context equals image draw dot draw and image. That would just be image. There we go. And let's double check the arguments on. And let me go ahead and toss you guys over here with me, just because it's one of those things I keep on muttering to myself here, and you guys aren't seeing anything, and therefore I'm sure it's very boring to listen to me read docs. So I am just making sure this is pointing to the correct window, because it never is, because I closed the other windows. And there you go. You are now over there with me. So anyway, going down to the image draw. Let's see. Image draw. Okay, no, it is just node. So back to VS Code with you. We do not need that. And then context would be, let's see, dot text, right? I see multi-line text. Where is text? Huh. Let's see. Text. Oh, I must have missed it. All right, there we go. And it has the same parameters as font.text. So we are good to continue as I was going. So ctx.text. This again is going to be 00. And then, as I mentioned previously, the text will be text. And font will be font, self.font. Self.font. And then self.text options. And after we're done doing that, according to the documents, I believe we can just forget that we have everything and just return the image. Yeah. So it's funny because it looks like we do not actually need to destroy the context after we're done. So we will just return image. And in theory, I think this should work. It's one of these things that I do not play around with text on PIL terribly often, so we should hopefully have a solution here. So where is, oh that's right, HUD is all the way down here. HUD, hike. HUD label, yes. Options self. And let's see, is there anything else we need in here? Size, font, no. We don't necessarily need those, so we should be good. All right. So that is the HUD counter. And we don't really need to provide any other values, I don't think, just yet. So let's go ahead and get this implemented over on tkintersample. Let's see. I am hesitating right now only because I guess I should also bring this in over here. It's one of those things, the HUD elements are always 2D, which is kind of funny. But again, the idea was to have everything imported from just one file so you don't need both sprite and two-dimensional. So for that reason, counter HUD, sprite.counter HUD, coordinate system equals two-dimensional four-way. There we go. And I guess that's really all we really need there. So really, we will hop over here. We will create a HUD. Print counter equals sprites dot, no, not sprites, two-dimensional dot counter HUD. Cmin equals 0, Cmax equals 0. Actually, we won't set Cmax because that should be infinite. And start can start at 0. So, anything else we need to add? Oh, label. That's what we need to add. Label equals prints collected. All right. And now that we've done that, that reminds me of the things we do have to actually add. Get text. We need to actually add get text because again, we're going to call that up here. Right there. Get text. Parent got text. Get text. So let us go ahead and implement that. define get text, whoops, text self return self.label. Define get text plus self.value. There we go. And that should be kosher. Yep, that should be everything. So, back over here. Print counter label. The value can start out at 0, that's fine. And now we need to come up here to unpause printer and print counter dot value plus equals 1. And. Yeah, you know what? Let's add it to sprites and back to the idle. Text. Let's see here. Yeah, actually we don't need... Yeah, we're good. We're good. We do need, however... Right here. I messed this one up. Animations. Animations. This for value and values. We're going to need idle here. And we can make that an empty thing. That is fine. But we do need to provide at least idle on the default one. Again, we can change that in other iterations, but the default one should have at least that. So, in our iteration, I am going to go ahead and actually add that in. So, animations equals idle. And let me double check that we're doing this correctly down here. Canvas animate idle sprites. Let me just double check on that guy. F12. Cycle idle. Canvas sprites. Cycle idle. Yeah, okay. So in that case, if we do want to treat this as an idle sprite, we are going to want to do that. The question is, do we want to? So the question is, and the reason I'm stopping here, is that, well, first let me just do this. So in here, in theory, is going to be where our options are for when we customize this text. But, if we add this sprite to sprites, so sprites.append print counter, right? It will be generating the text on each and every frame, which is not necessarily what we want, right? There's a couple ways we can do this. So, if we want to avoid generating the image over and over and over again, we can either do it on change, or we can cache it, which makes sense, right? Caching it makes sense. It's an interesting dilemma, which one we would prefer. So this whole entire drawing deal with this animation, yeah, you know what? We'll cache it. So self.previous value equals start. And if self.value equals self.previous value, self.cached image equals none, and self.cached image return self.cached image, self.previous value equals self.value image equals, oh, this is get text, my bad. This is not where we want to be. Get image is where we want to be. We want to override get image. So let's cut this, return, define get image, self, there we go. If self.value cached image, there we go. Otherwise, image equals super.getImage self.previous or cached image equals image return image. There we go. Now we're not generating the image each and every time, which is useful. Our animations normally do not generate each and every time, right? We load them once up at the beginning and then put them out as we need them. So we don't want to be continuously generating this, the alternative, I guess it really depends. So there's, so this is a memory versus CPU power issue, right? So for caching the image, we can either cache all images for all values we have, in which case that saves us CPU time in the long run. However, that does obviously cost us memory because we're storing each and every single image. Alternatively, we can only save the most recent one, which means that if we bounce back and forth between 1 and 2, let's say on our counter, so our counter goes 1, then 2, then 1, then 2, in that situation, then we're constantly recreating the image, and that's a little bit of a problem because that's using up more CPU. On the other hand, if we're only ever counting in one direction, so if we only ever increment and we never decrement, which is what we're doing in this specific example, then caching all the different values actually doesn't make sense because we're never going to decrease the value, the ones that we had before. So there is that. The third option, the third thing to mention, is that we could have a base image for just the label, and then we could tack on the value afterward for the counter. So we could cache the label itself and then paste on the generated text value, the counter value on after it. That is another option. That's also extremely viable. Saves us a little bit of time. So I think we're going to stick with this for right now, but those are things to consider. So let us move on. Let us see. Get image, cycle print. So we do have it on idle already. So because we have it on idle, it can be in idle, that's fine. Yeah, I think we're actually okay in that scenario. So let's go ahead and run this and see what happens. So I will close out the previous version. Let's turn it on really quick, and then I will close out the previous version and rerun it and see what happens. And we got an error. Loop type frames, list frames. Object is not iterable. None type object is not iterable. This is inside of mobile sprite. How did that happen? I actually don't know how that happened. Let us look at what we're looking at here. So over here in sprites. Sprites, where you at, my boys? Turn off algorithms, turn off GIF, turn off sample. Do not need engine at the moment. Where did sprites go? Oh, duh, that's right. It's the same thing as this. So it is saying that we get here. The error message is saying that we get here, loop type gets set to animation, and then we go to frames. This is where we're failing right here. Which is odd. 64, so it's loading from line 64, which is animation loop. So that makes sense. Print KW. Let's see what that does. Okay, so the values look... Oh, animation loop type. That is where we are screwed up. My bad. So I have this animation loop type right here, and then we just pass that off to animations, and that should just be loop type. Alright, let's run this again. Delete option size. Okay. So over here, underneath HUD, actually HUD's up here, isn't it? There we go. So this stuff, size is not an option right now. So if size in, options, if font in options, there we go. That should fix it. Yeah, okay, so remember when... So our next error is this line right here, self.font. And I will now kick you over to the docs. So you may recall that I said that looking at the docs, TrueType did not have any. Do we have a version of that over here? Let's see, TrueType. Yeah, I don't see it over here, but if we go to follow this link right here. Where was that link? Font. There we go. Not there. Never mind. Text. Text. There we go. Image font. Here we go. So as I stated, TrueType, and you'll be able to see the says font none. So because it says font none there, I assume that none is a valid value. Otherwise, why would you have that as default value? I'm going to go ahead and source, which is not something I did before. Font none. Font free type. Try font free type. OS path. Raise. Yeah, so there is no default. It doesn't look like. Here's load default. Huh, that's funny, because, see, load default is a value. Define. Okay, no, that is another function. So, load default, where is that? Okay. Let's see. All right, you know what? We are going to solve our problem like this. Times. There we go. We have solved our problem. You cannot see me solving our problems because you're still over on the docs. So there we go. We're going to change options to times. And we will see, hopefully that solves the problem. And I still have a print in here, so let's get rid of that. Save and run. String object cannot be interpreted as an integer. Options.pop parent. Options.pop parent. Options should be a dictionary. Why is options not a dictionary? It should not be an index. Indexable. Let's see. What went wrong? So right here, idle. This is our options value right here. And as you can see, that is a dictionary for value and animations.values. So this functioned correctly. Parent equals self. So that functioned correctly. So back up here, print options. And let's see what we get. Parent. Okay, so that is correct. And then we get another one. So what are you coming from? Super animations.loop. Two-dimensional counter hub. Animations. That should be correct, huh? Why are we getting two values here? Interesting, fascinating. Self.animations equals animation loop. Loop type, animation, loop type. Huh, alright, so let's roll up to here, because evidently it's sounding like we have more than one frames. So print animation frames, and we'll see what that kicks out. X, huh? That prints out X. Why is there an X? Oh, I know why. I know why. We get hijacked. Right here. This is why. How do we handle this? So basically, this code in here pre-populates it with all the possible coordinate directions. So what we actually want to do is delete this. No, we don't really want to delete this. We don't want to delete this because this may end up also affecting location in the future. So we don't want to actually delete that. All right. Our solution here is probably Huh. Yeah, I don't, it's difficult, right? And this is one of the problems with duck typing like we are, is that you do run into problems like this occasionally. So, if we don't remove the coordinates system, we have this in here to make sure that all the animations are defined correctly for the mobile sprites. Everything else doesn't actually care about the mobile sprites. I guess maybe it was an error to do this, because again, the mobile sprites are the only ones that actually care about directions. I guess that's not necessarily true. A sprite may not be mobile, but it may still have a facing, would be the counter argument. So this may not necessarily be incorrect. So how do I want to handle this? Yeah, it's funny. Hour and a half in, and this is the first time that I'm feeling a little bad about this. Again, testing out the whole entire live coding thing. Everything else was going acceptably. I didn't actually mind it too much. Up until this point, because this does take a bit of consideration. One of those things, we may have been wrong from the very beginning about how we're handling the animation loop itself, or the animation object itself. That is definitely a possibility. So this could come back to HUD label is not a subtype of animation loop. So we can't do it necessarily like that, but what we could do is go back to the original thing I was talking about, which is inspecting frames 0. Alternatively, yeah, okay, so if yeah, okay, that's what we can do. We can do this. Take this out. Take that out. Take that out. Do that. If frames and frames 0 not is instance, frame 0 pil or image. This may be an error in the future. This may be something we got to resolve in the future, but for the time being, we can use this. Loop type equals frames.pop0. So this is originally what I started typing at the very beginning, if you recall. We'll go back to this now. I had deleted it really quick because I thought this was a little messy, but at this point, this makes our life easier. So we will go ahead and do this. So we can get rid of this right here. Get rid of this right here. Come down here. Get rid of that right there. Get rid of that right there. Let's see, anything in here? No. Okay. There we go. And now for the animations. What we want to do is this now. So the expected value animations for the counter HUD is going to be a length to list. Actually, no, it doesn't need to be, right? It doesn't need to be. We can actually deconstruct animations and then reconstruct animations. Okay. Can we? Can we? Can we? That may run into problems in the future, back to if we have animated text on the screen that once animations apply to it. That may be an issue in the future. However, we can cross that bridge when we get there. So this is going to be a list. We actually don't want that. Okay, here's actually, this makes more sense. This makes a lot more sense. Animations equaled none. Animations equals, and then this is font options equals none. If font options is none, font options equals that animations equals idle. This is HUD label, and then font options. Font options parent equals self. There we go. That makes a lot more sense. Okie dokies. Yeah, so now we're just going to assign animations ourselves here and assign HUD. Again, this may end up causing us problems in the future, but for the time being, it will work. So. Oh, actually, here's another thing we could do. Labeler equals font options dot get. Actually, really quick. Python built in, or not built in, no. Mapping, or let's just say dict, because whenever I do mapping, it never comes out correctly. It never takes me to the correct place. I always have to go dictionary objects, or no, data structures. That's what it is, data structures. And then click the link in data structures to mapping types, because for some reason, again, I can never actually get the, there we go, the correct thing I'm looking for. Does pop provide a default value? It does. Okay, pop does provide a default value, which is good. So let's come up here. That's something I should have checked back when we had this problem. Pop. We can do that. Now we don't need the other stuff. Not poop, pop. All right, and back down here. Dot pop. What do we call this? We can call this animate. Well, I have it labeler. Yeah, let's call it animator instead. That makes more sense. Dot pop animator, and that would be HUD label. And now we can provide, if we want to have a different labeler, a different thing to push to render to the screen, we can provide that as an argument now. So we just change this to animator, and off we go. And come over to... Yeah, okay, just double checking myself. This sample, and this is now font options equals, and this dict will just be empty for now because we are not actually providing font options. And let's see what happens. Image object is not subscriptable. Frame 0. Load character. Animations. Huh. That makes less sense. Because I just looked at animations, and animations was a list of I literally just printed it out. Like, I can see it above, right? I can literally see it in my... Here, let me turn the PowerShell window on so you can see it. So this was the last time we ran it, which is where I went, oh, wait a second, this is obviously not working here, and that's our error that I was talking about. And here now it's saying that frame 0 is an image. Or, not frame 0, frames itself is an image, which makes less sense. As you can see, it says that it's under load character and mobile sprite. Oh, idle. I see what I did here. Idle is... Understood. Okay. So that was actually an error way back when. So, tika inta. Let's see. Idle equals. Direction is down like that. So now that is a list. And our character never actually idled before, which is probably why we never got an error. So let me, however, before I make that claim, not that I didn't already make that claim, but look at how it initializes this animation frames 0. So this is when loop type frames. So this is where we're at before. Ah, I see. So before we caught it. Before we just caught it. Okay, in that case, since we're catching that and I can understand the rationale behind that, so let me hit Control Z here. Come back over here, and we'll just change this. If not... Or actually, yeah, we can reverse this. We can reverse this, and frames. So it's not an image. If it's not an image, then it should be a list. And actually, we can do both. And all right. Frames 0. All right, cool. So what we got here, we have not a single image, and this is not JavaScript, not a single image, and not none, and falsy, and frame, which means that it should be a list, and the first index of that list is not an image. There we go. First index should be a animation loop type object. There we go. So that explains that one. So let's run this again and see what happens. Options.parent.pop parent. Right. Loop type. So what it sounds like is we're actually back to our original problem where we're getting a list and the list is not accurate. Because we're initializing in 95. 95 should be HUD label. We are. And let's see. The odd thing is that oh, that's what it is. Down here, this options is actually a list, okay? So, options equals options 0. Options is passed in as a list bundled with HUD label as its animator. There we go. And we run it, and sprite.location. So we're adding the HUD to the thing. Axis step length, none type is not iterable. For axis and chord. Ah, I see. We did not actually set the location. You see how we set me.location, etc., etc., etc.? We did not actually set that location on when we generated the printer. Let's see. Location equals 0, 0. Let's do that. Oh, I thought I changed this. Okay, evidently I didn't change this. So over here, I thought I provided for location in here, but I did not. So I guess we will have to do it the long way. X printer counter print counter dot location equals 0, 0, and let's see. Subclass has not implemented get image. Yes, it did. Super get image. Oh. Shoot. Get image not implemented. Get image. Yeah, okay. So this comes from the past. This is a problem from the past. You'll notice that how every single one of these has the same exact get image description right here. They all use the same exact get image. And that is because originally I wasn't going to use self.animations. So what really should happen here is that I should just default to the same exact get image on sprite, because at this point I'm pretty sure everything is going to function the same exact way anyway. So for that reason, we will just move this up. There we go. Okay. Self-taught text cannot concate string to string. Oh, can only contact. Oh, derp, that's right. Not JavaScript. Not JavaScript. Where is HUD? HUD. Hike. There we go. String. Not JavaScript. check size. Size must be length 2. So that is an issue in the HUD label. So print size. Print size 027976.9. Interesting. What is, we'll go ahead and kick you over to Edge. And where is this? Nope, not that. Pillow. There we go. So get size, it's saying, is that would be on our font, so that should be over here. Get bbox. Oh, we're using get bbox, right? Not get size. That would explain it. Okay, that being the case, there is no actual get size anymore. So what we want to do is, since we got a bbox, we want to subtract right from left and bottom from top, right? So this would be size 2 minus size 1, or size 0, size 3 minus size 1, and that should be accurate now. Let's see what happens. All right, more errors. Current index. Set animations. So let's kick you back to VS Code. As you can see, I got errors. So let's go ahead and close this down. And it says, the funny thing is that I thought we duck typed this. So which is the in cycle idle in set animation loop dot current index equals 0. Okay. We will do this. At property, define current index self return 0. Define, or at current index dot setter, define current index self value return. There we go. That should fix that, hopefully. And our error this time is frames. HUD label has no attribute frames. So back to duck typing. This is another one of those errors. Set animation. Let's see. Set animation. Loop dot frames. Yeah, okay. So let's do this. Loop dot current frame. That is fine. I did define that, right? Current frame? Yes, I did confirm. Fine. Do that. All right, run again. Let's go. And cycle takes one positional argument, but two were provided. HUD cycle self value, or actually, let's just do args quargs and ignore everything. That will fix that. All right, there we go. And as you can see in the top left here, we have some rather janky. Let me see how it looks on stream. Okay, let's switch you over to the other one then. So as you can see over in the top left, we have some pretty janky looking text, but we at least have text, right? And it is incrementing. So this is a matter of getting that fixed. Now the interesting thing is that the font size appears to be wrong, which is fascinating because it's cutting off the bottom. So that would mean that, let me kick you back to VS Code and we'll go ahead and close this off and minimize this. Let me just look. Yeah, we didn't get any errors on the PowerShell. So that sounds like the text size is giving us the wrong size. So let's go ahead and print size, and we'll go ahead and check our math here because maybe I screwed this up. Otherwise, we are putting the text in the top left hand corner, so that should be maximizing. So it shouldn't be, this shouldn't be an issue right here where we're putting the text, but that's the only other thing that I can think of. I'm going to really quick look at, and I'm not going to swap you over because this should just take a second, the docs just for drawing. And the docs for image font. I know I said this was going to take a second, and this is a little bit more than a second, but you understand me. Image font. Yeah, so get bbox returns the bounding box and pixels of the given text. Left top, right bottom, which is what I expected. That's why it's -2 -0, right? 0 1 2, yeah. So the bbox is described as I expected. Huh, interesting. All right, so yeah, I don't actually know. Again, we'll run this one more time to see what it prints out. It did not print out anything. Did I not save? I did not save. Okay. Close that up. Try again. Did I just do something over here? Yes, I did. Okay. Close that up. And it is saying... Alright, so the math looks to check out, right? The one thing that's interesting is that it appears to be printing non-stop. Yeah, it's printing non-stop, which is not correct because we should be caching the image over here. So it should not actually be calling that. Get image. Cache image, self.cached image, self.value equals self.previous, self.previous equals self.value. And cached image is image. So let us add this, print self.value, self.previous value, self.cached image. And we'll close this out and clear and run again. And what's that say? Oh, that's funny. So it is only calling it once every time we collect, it looks like, which is correct. That is definitely correct. The odd thing is that we should only be calling get image in order to prompt the printout up here. Let me minimize this stuff so that you have a better view of the, the code. Right, we're only printing when we do current frame. Actually, so when are we calling current frame? Oh yeah, we're calling current frame. Okay, we're not calling get image. We're calling current frame animations.current frame. So it's part of this. It's part of the cycling on the canvas. Animate sprite.cycle idle, and then sprite cycle idle. So self.animations.cycle. So up here in cycle, self.current frame. Right. So that is what's happening there. That makes sense. Parent get text. So we can move the information up one level, I guess, is a solution. So instead we can do self.last value equals none if self.last value and self.last value equals text. Return or actually, yeah, and self.cached image. Self.cached image equals none. Try that again. There we go. Return self.cached image. There we go. Self.last value equals equals text, and self.cached image equals image. And there we go. So bring this back up, close this out and start again. Clear and run. And yeah, so as you can see, now it's only calling it every time we increment, which is what it's supposed to do. All right, because we're using cycle idle. Again, if we decoupled idle from the other stuff, if we did not have this as an idle sprite, then that would not be an issue. Now, the only question is why the top is, the bottom rather, is cut off. That is a question. The font, again, we can fix. We can change the font to be something better looking, but the other issue being that the font size does not appear to be correct. Let me close that and minimize that so it's out of your way. And let us look over here at tkinter and see whether or not that is involved, because that is the other aspect in here, which is that add sprite, create image, sprite.location times scale. Image is the photo image. Sprite.getImage. Set sprite animation. Scale. The reason why our text might be looking janky could be because of the scale. So that actually may be something we need to decouple. Photo image. Item configure. Image equals photo image. Photo image. And we call this set animation when our animation current loop has changed or the frame has changed. So that actually should not come into play here. Actually, it should, shouldn't it? because the current loop should stay as idle, and the current frame is actual image object. So yeah, that will come into play often. So. Location time scale, blah blah blah, photo image. I guess what we can do is really quick check here. Print image.size. So we can check this, and this is the last thing I'm going to do tonight because we do have D&D tonight, so I will be getting off in just a minute to get ready for D&D. I am DMing, but we can at least check that. So, image size. Okay, that is not going to help me. What I'm going to have to do is do that down here instead, and let us close that and retry. Okay, so we're bouncing back and forth. 105, 160. Oh no, that's 380, 35. 76, so 380. Calculate 380 divided by 5 is 76. Okay, yep. So that is the correct size. So this is the size that it is scaling to. That is in theory the correct size, because our normal size is 76 by 7, which the image itself confirms right here, right? So the image 76 times 7 is correct. The 76 times 7 is what the text thinks it's going to be. So the last option here is actually to check the docs, because there's some potential that the text gets anchored differently from the top left. Anchor defaults. No, it says it anchors to the top left. Okay. Let's see. So yeah, I am more or less stuck here. Now, on the bright side, we did get the... this session, we did get it obviously implemented, which is good. I'm going to go ahead and minimize this now. So we got the counter implemented, which is good. I would have hoped to also get the bars implemented, but obviously we ran into situations that I did not anticipate, unfortunately. But, you know, at least getting one of the two done is fine. The weird thing is that it's saying the text is supposed to be X size. We're putting the text in the top left, which should take care of that whole entire dealio. So everything should line up, and it just isn't. I will investigate further, and we will see where we go. The weird thing is that my final hunch here is that the bounding box, the text size bounding box, which actually is up here, isn't it? So the bounding box is the text itself, the colored text itself, but the text has white space around it is my best guess, and therefore that white space is not accounted for in the text box. So when we create the new image, when we image draw the text onto it, the image draw, this text right here, ctx.text, actually implements white space above the text. That's the best I've got for you. So it doesn't sound right. The docs don't suggest that's what it does, but that's my best guess at this point. Again, I will look at it off stream before we do the next section of this, and hopefully have it fixed so we can move right into getting the bar on there. And once we have the bar implemented, that should be everything, and we should move on to actually just creating the loading screen, the BRB screen, etc., etc., etc. And again, that will be a separate program that will implement this one, and then we'll be done at that point, at least until we find something else to use the program for, which is the intention. But regardless, that is everything from me. I do have to run to go DM, so thank you guys for watching if you have been, and I hope you have a great and wonderful great and wonderful D&D, a great and wonderful day, afternoon, or evening, there we go, wherever you're at in the world, and I will catch you next time.